Welcome to the debate. Has the era of generative AI killed the creative craft of software development? Are we turning this deeply creative engineering process into a rote, mindless exercise of reviewing machine-generated slop? We are diving into a fundamental question today, one that really cuts to the very heart of what it means to be a creator in the modern age. And we really want you to be part of this conversation. So please, right off the bat, share your own experiences and thoughts in the comments below. Is AI destroying your creativity, or is it setting it free? Today, we are examining a critical inflection point emerging from recent software engineering literature. The central question is this: is AI-assisted programming destroying developer creativity and long-term sustainability by drowning experts in technical debt? Or is it elevating the craft by freeing developers to focus on higher-level system architecture and creative problem-solving? I will be arguing that AI fundamentally elevates developer creativity. By automating mundane boilerplate and lowering barriers to entry, it allows developers to focus on high-level system design.
And I will be arguing that the current trajectory of AI adoption actually degrades the creative craft into a grueling maintenance grind. Instead of being liberated, experienced developers are being stripped of their original creative output. They are being relegated to janitorial roles, essentially forced to manage massive spikes in technical debt and unprecedented security vulnerabilities.
To begin, I want to articulate that AI is not destroying creativity. It is fundamentally evolving it. If we look at the history of computer science, every major leap forward has been about moving up the ladder of abstraction. Decades ago, writing machine code by hand was the craft. Then we moved to assembly, then to high-level languages like C and Python, which abstracted away the tedious reality of managing memory directly. AI assistants like Copilot and ChatGPT are simply the next rung on that ladder. They are abstracting away basic syntax. So the creative act isn't dying, it is just moving from typing lines of boilerplate code to architectural problem-solving and rapid prototyping.
But moving up the abstraction ladder historically meant we were creating more robust, reliable tools. What we are seeing now is fundamentally different. This so-called evolution actually traps developers in a vicious cycle of rote maintenance, which systematically extinguishes original creative output. We have to look at what is happening to the human beings actually maintaining these massive software ecosystems.
You don't think abstracting syntax allows for better system design? We can see this shift happening right now at the institutional level. I mean, Columbia Engineering has actively redesigned its programming courses to reflect this new reality. In their object-oriented programming electives, the focus is entirely shifted. Students aren't just writing code from scratch in a vacuum anymore. They're evaluating AI-generated code for correctness, efficiency, and design patterns.
The future of engineering is about the big picture. Junior developers are coming in with fresh perspectives, orchestrating AI and focusing on prompt engineering. They are asking the why of a system, which is the true core of engineering creativity.
I come at it from a different way. Grading an AI's homework is not the same as learning to architect a system from the ground up. Recent data studying open source projects right after GitHub Copilot was introduced provides an incredibly sobering look at this dynamic. Researchers found a fundamental tension between short-term AI productivity and long-term system sustainability. The data shows a massive divide. After these AI tools were introduced, your veteran engineers, the core maintainers, experienced a nearly 20% drop in their original code productivity.
Because they are spending their time elsewhere, managing larger architectural integrations.
No, they are slowing down because they are playing janitor. Instead of doing the creative architectural work you were talking about, they are being forced to review significantly more code just to manage the influx of low-quality AI-assisted submissions. The craft is being replaced by damage control. The creative joy of building a cohesive system is being buried under the cognitive burden of reviewing disjointed, machine-generated patches.
I see why you think that, but let me give you a different perspective on what those numbers actually represent. You frame that influx of code as a burden, but let's look at the massive productivity gains shown in that exact same material. While the veteran developers might be shifting their workflow toward review, The junior or peripheral contributors, the people who historically struggled to make an impact, are seeing their outputs skyrocket. Their commit activity is up by over 40%.
But what is the quality of that output? That is the crux of the issue.
The quality will improve, but the immediate impact is the democratization of software development. By lowering the barrier to entry, AI is unlocking creative participation for a much wider, more diverse pool of minds. People who previously might have been blocked by the intimidation of complex syntax, or who just didn't have years to memorize specialized libraries, can now contribute to open-source infrastructure. The increase in pull requests isn't just noise. It is a surge in human participation and creative expression that was previously bottlenecked.
I'm sorry, but I just don't buy that. Let me tell you why. That surge in participation is exactly what is driving the massive spike in technical debt, creating what researchers call the speed-quality paradox. Yes, code is being written faster, but it is fundamentally flawed and underspecified. Let's look at the code cloning data from recent enterprise repository analyses. Over a 4-year period leading up to 2024, examining hundreds of millions of changed lines, researchers found a staggering 4-fold increase in code cloning. For the first time in history, copy and pasted code exceeded moved refactored code.
That just means people are finding working solutions faster and implementing them across the codebase.
It means they are engaging in vibe coding. This is the new trend where a developer types a vague, natural language prompt, hits tab, and blindly accepts a massive block of unverified logic. It creates an illusion of productivity. The foundation of the codebase is eroding because the AI is just vomiting up plausible-looking boilerplate that lacks any real architectural coherence. The core maintainers then have to spend their time untangling this duplicated mess. That is the exact opposite of creative system design. It is archaeology on a codebase that was written yesterday.
That's an interesting point, though I would frame it differently. The duplication and the rework you were describing are the growing pains of a new paradigm, not the permanent state of the craft. The solution to vibe coding isn't to abandon AI, it's to master the new creative language of the era, which is prompt engineering. Traditional coding relied on strict syntax. A missing semicolon broke the build. AI relies on linguistic precision, structured examples, and contextual framing. Prompt engineering bridges the gap between human intent and machine understanding, and it requires immense creativity and logic.
But prompt engineering is incredibly fragile. You are trying to coax a probabilistic model into doing deterministic work.
It is only fragile if you don't know how to do it correctly. Look at the recent systematic literature reviews on how large language models handle code security. The data demonstrates that sophisticated prompting techniques drastically change the quality of the output. When developers use chain-of-thought prompting, meaning they force the model to explicitly write out its step-by-step reasoning before generating the code, the results improve dramatically. Or consider role-oriented prompting. If you simply tell the model, you are a senior cybersecurity specialist reviewing this pull request, its precision in detecting hidden vulnerabilities skyrockets, reaching upwards of 74% precision. Junior developers are no longer just typing out functions, they are orchestrating AI workflows, thinking deeply about how to constrain and guide the machine.
That's a compelling argument. But have you considered the cognitive reality of what it actually takes to constantly prompt, verify, and guide these systems? There is a massive disconnect between perceived productivity and actual cognitive load. Recent neural imaging studies on developers actually measured their brainwaves using EEG and tracked their eye movements while they reviewed AI-generated code. The results were staggering.
Staggering in what way? That reading code is different than writing it? We've always known that.
Staggering in the sheer physiological toll it takes. Developers perceive themselves as being highly productive because the AI generates 50 lines of code instantly. But the actual cognitive load is immense. Reading and verifying AI-generated code is often much more mentally exhausting than writing it from scratch. Think about it. When you write a function, you know the logic because you built it. When you review AI code, you are essentially reverse engineering the hallucinated logic path of a machine. It's like grading the homework of a hyperactive intern who happens to have a photographic memory but zero common sense.
I think comparing an advanced large language model to a hyperactive intern severely undersells the utility of the tool.
I use the comparison because it highlights the strain on what researchers are now calling humanware. We focus so much on the software and the hardware, but the humanware, the developer's cognitive capacity, their burnout risk, their deep expertise is being severely strained. We have a shrinking pool of core maintainers bearing the brunt of this. They aren't creatively architecting, they're frantically reviewing code to prevent insidious vulnerabilities. Take CWE 284, for example.
Improper access control.
Exactly. Improper access control. The AI doesn't inherently understand the complex real-world context of who should have administrative rights in a specific enterprise system. So if prompted poorly, it just writes a generic, helpful-looking function that inadvertently leaves the back door wide open. Or it implements risky cryptographic algorithms because it pulled an outdated standard from its training data. Catching those errors requires intense, focused human attention. The human is being treated as an infallible compiler for the AI, which is a recipe for catastrophic burnout.
I'm not convinced by that line of reasoning because it assumes the workflow will remain static. It assumes a human just reads raw, unverified AI output in a vacuum forever. The industry is rapidly evolving past that. The cognitive load you are describing happens when AI is treated as a magic black box rather than an integrated iterative tool. When universities shift their curriculums to teach problem decomposition using AI, they are directly addressing this humanware component. They are teaching the next generation of engineers how to read, verify, and systematically improve code using the AI as a partner.
A partner that is inherently unreliable.
A partner that is statistically safer than many human alternatives. The same security reviews show that while large language models can introduce vulnerabilities, tools like GitHub Copilot are actually shown in some empirical analyses to be less likely to produce vulnerable code compared to a human developer copying and pasting from Stack Overflow. Furthermore, through iterative reprompting, where the developer spots an issue, points it out, and asks the AI to fix it, developers successfully mitigated nearly 90% of vulnerabilities in a multi-round fixing process. The cognitive load you mentioned isn't a permanent tax. It's an upfront investment in learning a new workflow. It's an iterative, analytical partnership.
But that iterative partnership is highly vulnerable to systemic failures, specifically regarding security and the integrity of the models themselves. You mentioned the 90% mitigation rate, but that entirely relies on a human expert being capable of spotting the vulnerability in the first place to ask for the fix. What happens when the underlying models are compromised? The literature points to severe emerging dangers like data poisoning and Trojan puzzle attacks.
Those are edge cases, highly sophisticated attacks that aren't reflecting the day-to-day reality of a front-end developer building a web app.
They are not edge cases. They are the frontier of cyber warfare in an AI-dependent ecosystem. Malicious actors insert subtly harmful data samples into the open source repositories that these models train on. A developer using an AI assistant trained on poison data is actively, albeit unknowingly, introducing severe vulnerabilities into their codebase. The AI isn't just making an innocent mistake. It has been taught to write the vulnerability.
Which is why we have code review and automated testing.
But the human review systems are collapsing under the weight of AI generation. We're seeing the rise of AI bias, where the sheer volume of machine-generated artifacts completely overwhelms human review. Look at the curl open source project. This is foundational internet infrastructure. They literally had to discontinue their bug bounty program because they were inundated by an avalanche of AI-generated security reports. Imagine a core maintainer waking up to 50 incredibly detailed, highly plausible security reports. They spend hours investigating only to realize every single one is a hallucination generated by a bot. The reviewer's attention was entirely consumed by unactionable slop. When the noise-to-signal ratio gets that high, the human in the loop fails because the human is simply overwhelmed.
That's an interesting point, though I would frame it differently. The overwhelming of bug bounty programs is a flaw in how we currently handle open source submissions, not a fundamental indictment of AI-assisted engineering. The solution to the security risks, the poison data, and the cognitive overload is deeper, more structured integration. We need to look at frameworks like Hula, human-in-the-loop LLM-based agents.
And how does adding more agents solve the problem of the human being overwhelmed?
Because it flips the workflow. Hula was recently deployed and evaluated at Atlassian, and it fundamentally changes the dynamic.
It isn't just an autocomplete tool guessing what you want to type next. It is a multi-agent framework where the software engineer actively refines and guides the AI during the creation of the coding plan, before a single line of code is actually written.
So the human is reviewing architecture instead of syntax?
Exactly. By evaluating this in a real-world enterprise environment, Atlassian found that this framework minimizes overall development time and effort, specifically by helping developers initiate robust plans for straightforward tasks. The human is kept securely in the driver's seat, creatively guiding the architecture, while the multi-agent system handles the execution. This directly mitigates the risks of both data poisoning and cognitive overload. The human is evaluating a high-level, human-readable plan, not hunting for a missing semicolon or a hidden cryptographic flaw buried in thousands of lines of raw output.
I come at it from a different way. Even with frameworks like Hula, the fundamental dynamic remains unchanged. The machine generates, and the human audits. As the volume of generation increases exponentially, and remember, industry leaders are predicting that the vast majority of all code will be AI generated within the next few years, the proportion of time a developer spends actually creating versus auditing continues to skew heavily toward auditing.
But auditing a high-level plan is creation, it's architecture.
No, it is editing, and that is the crux of the threat to creativity. Software engineering has traditionally been a craft of building, of entering a seat of flow, where you hold a complex, multi-layered system in your mind and translate it into pure logic. When your primary job becomes reading someone else's or something else's often flawed logic, that flow state is shattered. You mentioned the Atlassian deployment, but even in their own evaluations, challenges around code quality remained a stated concern.
Of course, there are concerns. It's a new technology. But the role of the engineer has always evolved.
But if most senior, capable engineers are spending their entire days checking AI-generated code for Trojan puzzle injections, broken cryptography, and massive duplications of logic, they are no longer engineers. They are editors. And here is the truly terrifying part. An industry composed entirely of editors will eventually lose the foundational knowledge of how to write the book in the first place. If the junior developers are only ever prompting and tweaking, where do the next generation of core maintainers come from? Who will understand the system deeply enough to fix it when the AI hallucinations compound into a systemic failure?
I'm not convinced by that line of reasoning because it relies on a very traditional, arguably outdated definition of what constitutes the book of software engineering. The craft is not the physical typing of syntax. The craft is solving the problem. If an editor is guiding an AI to produce a highly efficient, scalable, and secure system, that editor is engaging in profound creative work. They are designing the system architecture. We are simply moving up the stack. And to address the very real concerns you have raised about technical debt, cognitive load, and quality, the literature is already pointing toward a solution that we both can likely agree on. I'm listening. What is the solution to the cognitive burnout? The adoption of holistic tripolar code metrics. We can no longer just look at lines of code produced per hour. That is a factory metric, not an engineering metric. Recent reports argue powerfully that we have to measure the interaction between software, hardware, and humanware. We need key performance indicators that specifically measure developer burnout, collaboration practices, and hardware efficiency alongside traditional code quality. By establishing these holistic metrics, we can align AI tools to optimize for the health of the entire ecosystem, not just the raw speed of code generation.
I completely agree that we desperately need those tripolar metrics, because right now, the industry is flying blind. We are optimizing solely for speed, and the fallout is entirely predictable. But until those metrics are widely adopted, and until AI models are actually penalized for generating technical debt, my concerns remain incredibly high. The empirical data from the open source studies, the neuroimaging showing massive cognitive strain, and the staggering code duplication metrics all point to a current reality that is highly precarious.
It is a transition period, and transitions are always precarious.
But the stakes are global infrastructure. We are building massive digital infrastructures on top of code bases that are increasingly fragmented and fragile. They're being maintained by a shrinking core of experts who are experiencing measurable cognitive strain. Acknowledging the necessity of humanware metrics is a good first step,
but it is effectively an admission that the current trajectory is unsustainable. If we don't actively protect the cognitive health and the foundational ground-up coding skills of our developers, the short-term productivity gains of generative AI will be eclipsed by the long-term collapse of system maintainability.
This brings us to a clear point of convergence in our discussion today. We both agree that artificial intelligence is fundamentally, irrevocably altering the daily reality of the software developer. The old way of writing code is gone, and we agree that navigating this new reality requires entirely new forms of evaluation. We have to move beyond simplistic metrics like lines of code and embrace holistic frameworks that account for the software itself, the hardware running it, and the vital humanware, the cognitive health of the developers.
Exactly. We are in complete alignment that the human cost, the cognitive load, the exhaustion of reviewing AI hallucinations, and the shifting nature of the work can no longer be ignored or treated as an afterthought in the relentless pursuit of raw productivity.
Where we remain deeply divided, however, is on the ultimate outcome of this monumental shift. I stand by the perspective that this evolution, much like the advent of high-level programming languages decades ago, will ultimately liberate human creativity. By elevating the developer to the role of system architect and AI orchestrator, we are unlocking entirely new levels of problem-solving. We are allowing a much more diverse range of minds to participate in software engineering, moving from syntax monkeys to true system thinkers.
And I maintain that the empirical evidence serves as a stark warning we cannot ignore. The massive spikes in technical debt, the dangerous surge in copy-pasted, duplicated code, and the physiological burnout faced by core maintainers suggest something much darker. This technology risks suffocating the foundational craft of coding under an insurmountable mountain of maintenance, security auditing, and damage control.
The complexity of this material is vast, and there is clearly so much more to explore regarding how humans and AI will effectively co-create the software of the future. We've only scratched the surface of the underlying data and the real-world implications today. This is an ongoing evolution, and we'd love to hear where you stand on this. Please leave a comment sharing your own perspective. In your day-to-day experience, is the era of generative AI destroying your engineering creativity, or is it enhancing it? Thank you for joining us on The Debate.